Assalamualaikum warahmatullahi wabarakatuh. So guys, so today we go detail on equation of motion for translation. For translation, we have discussed before that we have two component of two type of translation. We have rectilinear and we have curvilinear. So even for curvilinear, I have discussed what the difference between curvilinear and rotational motion. Looks like the same if you don't understand it well, so you can say that you will get confused between curvilinear and uh, rotational motion. For rectilinear motion, first, rectilinear motion, we discuss about rectilinear motion. You have a bodies here, A, B, and the center G. So let's say it move to here. So you have A, you have B. Of course, it experience. We can say that it experience a rectilinear motion. Because you can see the path of B, path of G, path of A is similar, and the vector A equal to vector B with the vector B. Sorry, G. You can see that this is a rectilinear motion. Okay, so the equations for rectilinear translation is governed by, as we discussed before, summation of f in x. Let's say you have you have the axis here, x, y, is equal to m a g x summation of f in y m a g y n. And we still have the summation of moment as well. Even though it's so basically the summation of moments come from the derivation of rotational motion, but if you depend on these two equations only, maybe you cannot solve the problem. You need a third equation. But even though you use the summation of moment, but it's equal to 0 because ig alpha, since it doesn't rotate, alpha is 0. That's why summation of moment at g is equal to 0. Okay, or as we discussed before, instead of summation of moment refer to point G, you can have summation of moment P. For the example, point P is summation of kinetic element at point P. Okay, clearly if you see these figures, we know that it accelerates in this direction. So MAG, okay, MAG. So instead of refer to point G, you are referring to point A to find the moment. For example, you remain to use this equation, Fx is equal to MAGX. Of course, remain summation of y, summation of force in y in MAGY. Summation of moment at point A now is equal to, we don't have the rotational motion. We don't have the rotational motion. So this summation of moment due to kinetic element at K is equal to, at point M, and it is equal to MAG, MAG times D. Okay, that the equation for rotational for moment. Summation of moment at A is equal to MAG times D. Right. Okay, for curvilinear motion, curvilinear motion. So curvilinear motion is not rotational motion. Curvilinear motion, if I draw, I can draw it motion is something like this lah. A, B, middle is G. The final position is uh, somewhere here, for the example. Okay, without knowing the path, without knowing the path of A to A or A prime, we can assume this is a rectilinear motion. All right, you can draw a straight path here, isn't it? Because path A, G, and B is similar. All right, but we can assume from A to A prime. Uh, A to A prime, uh it has a straight path like this, but it has this kind of path. From A, it travel like this and goes to A prime. Similar to G. Similar to G. Travel like this. Okay. Similar to B. So for green path, A, G, and B, they are the same. But they are not linear. Okay. It has same path, but it experience a curvilinear. You cannot say that this one rotate. It doesn't rotate. It doesn't rotate, but it moves on the same path. The green path. This is curvilinear. Okay, curvilinear path. Curvilinear path. All right. So we have discussed before path. If you have this circular disc, your G is not in the middle. Your G is somewhere here. Let's say this is unbalanced mass, unbalanced wheel. So for curvilinear motion for these bodies, it will have what we call it A, G, G, N. Okay, two component, normal and tangential. And tangential is always to the center of uh, rotational. So this one A, G, T. Alright. For curvilinear motion, uh, instead of summation of fx is magx, magx. Instead of this equation in x, because we know that x is something like this, in this direction, this is the coordinate system for x and y. You can change it to summation of f in normal mag. Okay, instead of summation of f in y, magy, you can change it to ft. So you cannot simply change it like that, x to n, y to t. No, you have to really look on the problem, or on the problem itself, on the motion itself. You cannot simply change x to n or y to t. You have to look the figure, because sometimes for curvilinear motion, Sometimes you don't need the fn and ft. You can use directly fx and y. Sometimes you have to look the figure. We have to solve one problem. You can see the difference. How when you want to use fn or fx for curvilinear motion. And then we have another one. This is curvilinear motion. It doesn't rotate. Summation of moment remain at g remain zero. Remain zero. And then if you look to these figures, the summation of moment, if you choose point B as your reference, and it gives you summation of kinetic element at B at K at point B. Alright, you see that AN, AGN, and AGR. The moment if you refer to this one, this kinetics element give you MAGN time H, correct? Okay, MAGH time MAGN time H. MAGN time H. Plus, I don't want to discuss the positive or negative yet lah. So if you see this one, MAGR, if you draw a straight line here and you cross a perpendicular line to B, the distance from B to the force to the moment to the force or kinetics element acted by MAGR is E. So MAG T times E is time H. Right? That's the equation of motion for translation. And now after this, I will upload a few maybe one or two problems regarding to uh, equation of motion for translation. Okay, thank you very much.